Okay, so welcome back, and now let's do some examples. Okay, so the way we handle these for right now is we want to think to ourselves, remember with arc sine or arc inverse functions, inverse trigonometric functions, right? We always ask ourselves when we want the angle, when we're looking for an angle, even with other trigonometric functions. And we ask ourselves, okay, the tangent of what angle will give us pi over 2, right? We ask ourselves those types of questions, right, to kind of work backwards. With antiderivatives, when we start out, we're going to ask ourselves, what you want to do is ask yourselves, okay, the derivative of what function will give me this result? That's how you find the antiderivative. Okay, so when you want to find the antiderivative, you want to ask yourselves, okay, the derivative with respect to x of what function will give me 3x squared? Okay, so what function should I put in here? Well, think about this. How did I get that 3? Well, the derivative of what function will give me a 3 here? I've got a power here, right? And the coefficient and the exponent differ by 1. So it seems reasonable to say that, well, this is going to be x cubed, right? Because if I take the derivative of x cubed, I get this. So that means this is the antiderivative or an antiderivative for this. So that would imply that f of x is going to equal x cubed plus c, right? Why do I add the c? Because I don't know enough information to know what c is. So it could be anything, right? So this is the antiderivative of f of x. Okay, now let's do the same thing. Let's d dx of what equals 1 over x. Okay, now you have to kind of remember in your mind or in your repertoire of derivatives that you've done, you should recognize what you need to take the derivative of to get the given result. So here, ask yourself, derivative of what function gives us 1 over x? Well, that's going to be the natural log of x. Okay, so that means that the antiderivative is equal to the natural log of x plus the constant c. Okay, are you getting that? Now let's do the next one. The derivative with respect to x of what function equals cosine? So the derivative of what equals cosine? Well, that's going to be sine, right? The derivative of sine is cosine. So that means sine is the antiderivative. So the antiderivative of x, the antiderivative of f of x, I should say, is sine x plus the constant c. And then finally, d dx of what function equals e to the x. And of course, the derivative of e to the x is always e to the x. So that means, that implies that the antiderivative of e to the x is going to be e to the x plus a constant c. Okay. So notice how I always end with the constant c based on the theorem. Okay. Now later on, we're going to have more information that will help us decide in specific applications or specific situations where we can actually figure out what c is. But in the general case here, we have to have c because we don't know what it is. Okay, we just don't have enough information that can help us pinpoint what the value of c is. But we'll get there soon enough. Okay, have a great day.